So in this video I will demonstrate one way to tackle the Sinai road exercise. And I'll start just by quickly checking my elevation model, and I can see that it ranges from 0 to 2,565 meters, which sounds very reasonable for the area, and we've seen very similar values in Google Earth. And you can check its properties, and indeed the unit is meters, so that's good. That the unit is a distance unit is important because we're going to calculate some derivatives like slope, and therefore it's useful to have our units in a distance unit and not in an angular unit like degrees. That would cause problems. So we have our data, our elevation data there, and we have our road data there. So let's start by calculating the slope. We'll just search for the slope tool, and we've got it right there. So we can just take our elevation model. We've checked our units, and they are in meters, so the Z factor can just be 1, and that's it. So let's just run our tool. And now we see our slope map, and we can see that in here that the slope ranges from 0 degrees to almost 90 degrees, and we can see that the white areas are more steep slopes and the black areas are shallow slopes, and this makes sense. We see the area near the beach for lots of flat land, and we see the mountainous terrain here, and we see sort of steep slopes surrounding mountainous features. So that looks like what we want it to be. Next thing is to isolate the parts of the slope that are steeper than 22 degrees, because they are important for our analysis. So we'll use the Reclassify tool for that, and we'll do Reclassify by table. We'll open the tool, and we'll use the slope map that we just created. And there's only one band, so we'll use that one. That's this band with the slope information in it. And now we need to make a little table to reclassify it. So now it's just one, and we basically want two rows in there. One from 0 to 22 degrees, and we want to assign it a value of 0 because that's not so that's less than 22 degrees, and then from 22 degrees to 90 degrees, and we're going to call that a 1. And that should be all there's to it. So let's run this, and it's worked, and we've created a map where all the white areas are where the slope is steep, and this looks very similar to our previous slope map, except it's no longer a continuous scale, but we've isolated purely those areas steeper than 22 degrees. And then the next step is basically to use our road vector data and analyze it, and we're going to use some tools that use distance again. So we're not going to need to change the coordinate system of this, because currently the road is in the coordinate in a degree based system, and yeah, it's in a degree based system. So we're going to change that, and to do that we need to do the Reproject tool, Reproject layer. So pick our road, and we're going to reproject it, and we're going to reproject it to UTM 36 North. And if it isn't already there, there's a button here that we can use to find something else. So I can just type UTM here, and then we can browse all the different first types of UTM coordinates. And in this case I'll just pick the existing one, and that should do the trick. And now we have a reprojected road, and if we inspect this information, now we see that the units are meters, so we can now do calculations with distances. And the next step is basically we want to take samples along this road at equal distances. Now currently the line consists basically of a node here, a straight segment between it, and a node here, and a node there, and a node there. And so we basically want to add extra nodes in between it at say every 50 meters, and for that we can use the if you search for nodes, then we see that there is a densify by interval tool, and that does exactly what we need to do. We take our reprojected road, and we want to add nodes every 50 meters, and you can just run this tool, and now we have a densified road. And we could use turn this on and use the vertex tool to inspect this, and now we can see that we have now far more vertices than before. Let's just turn this off and turn the editing off, because we don't need to do any editing here. And then the next step is basically to extract all these nodes so that we can actually use them to sample things. So that is vertices, extract vertices. We take our densified road and create it into a new temporary layer, and now we have all our vertices, and we can see all of them. They're just circles, and they're a bit small, so we're going to make them larger so that they can be used to sample within a 200 meter radius, so that we can detect slopes steeper than 22 degrees within that radius. For that we need to use the buffer tool. Buffer tool adds, so before we got the right layer here, and we just add a 200 meter buffer. It will draw a 200 meter wide circle around, or a circle with a radius of 200 meters around our points. So we run this tool, and now we get all these circles, and with a 200 meter radius, and we can use this to sample our raster layer with the slopes in there. And to do that, we use something called zonal statistics. So if we look for zonal statistics, this tool, we select first the raster layer, which is our classified layer, and then we use our buffered shapes, and we can choose which properties of which statistics of the raster layer are added to the count. So it will count the number of pixels that is one or bigger, or it will count the number of pixels in there. It will sum them up, and in this layer we have only got ones and zeros. So the sum will basically be the number of pixels representing an area of a slope bigger than 22 degrees. We could add more, but we basically only need the sum in this case. So we can click OK, and we can run the tool. And it was successful. And now this tool hasn't created a new file, but it's added extra data to the buffer layer. So we can open the attribute table and fit it into the screen. So we have our circles, and then all the way at the end there are now 3 new attributes fields: count, so the number of pixels in each circle, and the sum, which is the number of pixels being 1, and mean. And this sum is a very useful measure for our analysis, because it tells us the number of pixels where the terrain is steeper than 22 degrees within our circle. So that's actually a very good measure for our simplified rockfall hazard. So we're just going to visualize that. So we're just going to go to properties, to the symbology. Let's fit it into the screen. Symbology. And now we're just going to do graduated symbols. And we pick this sum variable. And we're just going to scale this from, let's make a new color ramp, which is a bit more intuitive. So let's just go from green. Where we have relatively few pixels with steep slopes, to red where we have many, and maybe at a yellow band in between here, so because it's a bit nicer than that. And the previous grayish color. So let's add this to our layer and classify this, and now we've created this mesh where here we see there are many steep pixels within a 200 meter distance of the road. So this is clearly a dangerous area, and the green areas are relatively safe areas with relatively few steep slopes. Now let's remove those black outlines. We're going back to symbology, and we go back to the symbol, and then in here, maybe advanced. Oh yeah, we need to click here, and then we can set the outline to no pen. Now we've removed the outline, and it should do the trick. Yes, that makes our map look a lot nicer. So now we've created a good indication of how many steep slopes there are near the road. And we can make the background map look a little bit nicer. Let's remove the in-between data that we don't need. Let's remove slope. Let's make the elevation a little bit nicer. Symbology. Let's not do gray, but let's do a pseudo color. And is there any good model or color map for terrain? Not really. So just let's create a new one. And blue for the sea is good, but then stick some green right next to it for the shallow parts. Let's make it a bit less saturated, a bit darker. And so from green we can go to yellow. Let's make it a bit nicer. And then we can add a brown somewhere here. Somewhere like this, and a gray, somewhere like this, and a white for the highest peaks. And that looks like a decent color scheme for a terrain. So let's do it like this. Let's apply. That looks pretty decent. Now let's just add a hill shade. Calculate the hill shade for this thing. I've got the elevation model, I've got everything else. Alright, we've got our hill shades. Now let's just make our hill shade nicely transparent by changing the blending mode. Let's change the blending mode to overlay, and that should do the trick. And that's could maybe still be a little bit nicer, but that's basically should do the trick. Alright, so that was one possible option to tackle this exercise. There are many more, but this is just one way of doing it.